software opens as such, right? Home position again, that's how it opens. So if the next thing on our hit list would be an X-ray map. So how I recommend acquiring an X-ray map is, I will first collect the spectrum and just label the peaks that you want to map. If I lower this magnification, for instance, let me give you some more information. Like this is that big piece that's in there. Is that correct? This was a big. Yeah. This was a big piece. Yeah. There. No. Yeah, that's fine. We can do that. So we found the elements that we want to look at. And so after we label the elements, we can go straight to work with maps, review the map properties. So this is how it's acquiring the X-ray map right now. So in a 200 millisecond dwell time, the resolution is 256. And that approximately takes 11 seconds per each frame. If I change my dwell times to, let's say, 50 microseconds. And I change my resolution to 128. Even better. So every sweep's going to be 2.9 seconds. So I told that I want to do 1,000 scans. I'm not worried about drift correction or anything like that right now. And so this will be a very fast scan. I just changed my defaults. I like the map that way better. So all right. So after we put in our parameters for map properties, we could select our elements, but the elements are already selected because we already labeled from the Spectra, so it remembered that. And so the only thing I need to do next is acquire the X-ray map. But realistically, I could have went in and just told it just a map, and I could have come in later on and just labeled all these. So it's doing a 2.9 second sweep at 3,000 counts a second, and so we're just going to let this thing just develop. That's basically what we're doing. And you can sit here for 5 minutes, you can sit here for a minute, you can sit here however long it needs to be in order for us to see what we want to look at. I mean, the sample is mainly iron. Now we're starting to line up some of the carbon over here.
That's where the glove is.
Yep.
Right, yep.
So if I hit stop, right, because I don't feel like waiting for 1,000 sweeps. So you hit stop, and then as you follow the flow chart, right, annotations, you can come in and annotate any one of the X-ray maps. Just right click on whichever map you want to annotate, and then you go edit annotations, and see it's annotating the SEM image there, right? SEM. And so if I was to right click on the carbon, I could just go edit annotation. See it's annotating the carbon map. So if I was to move that, I could throw up a window here and I could annotate that. Anyway, just showing you can annotate individual windows. The next thing we see is view map data, and as we throw this window up, wherever I decide to left click my mouse and start dragging it around, now I only acquired this for 6 seconds or whatever it was, it'll give me information. It's called position tag, so it'll be to acquire a lot longer. So, but if I change it to concentration, and if I go rectangle, and let's say if I want to draw a box there, it'll go through, tag that location, 50% carbon, 84 iron, 0 nickel, right? So it's pulling information out of the X-ray maps, right? Because it spent all that time accumulating that data, so it can pull that information out. Which is pretty powerful. Okay, let's kill that. And as we go down, overlay map, so here you have the SEM image, right? Show me where the carbon sits, right? And let's change our level of transparency. So you can see the carbon is really dense in this little area right here. But again, we acquire this very, very quickly. Right? Where's the iron sit? Right? Basically everything's iron. So mapping, the longer you accumulate the data, the better. And then obviously back to export, and how we export it all individually, or you can export it as it's displayed.
Now, can you, like say when you had the carbon map superimposed over the image,